Welcome to today's journey through the cosmos, right here on our channel. In this episode, we're diving into a recent headline grabbing discovery by NASA, an object hurtling out of the Milky Way at incredible speeds. What is this object? Why is it traveling so fast? Stay tuned as we unpack this cosmic mystery. NASA, citizen scientists have made an incredible discovery, an object racing through space at nearly 1 million miles per hour. Known as CWISE, Joan 1249, this faint but fast-moving body could be a low-mass star or a brown dwarf, a celestial object that sits right on the edge between a star and a gas giant. But what makes this find even more fascinating is how it ended up hurtling out of the Milky Way. Scientists believe it might have been ejected by a supernova explosion or a close encounter with a black hole. In today's video, we'll dive deep into the discovery of CWISE, Joan 1249. We'll explore the science behind it, discuss what makes it so unique, and explain why this find could change what we know about our galaxy. So, let's jump right in. This thrilling discovery was made possible thanks to data from NASA's Wide Field Infrared Survey Explorer (WISE) mission. The mission has been a game-changer in mapping the sky using infrared light. Citizen scientists Martin Katnick, Thomas Blue, and Dan Salon first spotted this hypervelocity object zipping across space. Initially, it appeared as nothing more than a faint blur, but further analysis and follow-up observations using ground-based telescopes revealed something truly extraordinary. What sets this object apart is its surprisingly low mass, which makes it tricky to classify. Could it be a failed star, or perhaps something else entirely? While scientists are still working on definitive answers, the possibilities are exciting, and this discovery opens up new questions about the nature of fast-moving objects in our galaxy. It turns out this mysterious object could be either a low-mass star or a brown dwarf, often referred to as a failed star because it didn't gather enough mass to kickstart hydrogen fusion in its core. Brown dwarfs are quite common, but what's truly unusual is how fast this one is moving. Typically, brown dwarfs don't zoom through space at such incredible speeds. In fact, citizen scientists involved in the Backyard Worlds Planet 9 project have already discovered over 4,000 brown dwarfs, but none have been seen hurtling out of the Milky Way at such breakneck velocities until now. This object's extraordinary speed and unique path suggest it was violently ejected from a larger system, possibly due to an explosive event like a supernova or a close encounter with a pair of black holes. Even more fascinating is that the object's chemical makeup hints it could be ancient, perhaps even originating from one of the first generations of stars in our galaxy. That would make it not just fast, but historically significant. The excitement among the citizen scientists who made this discovery is undeniable. Martin Katnick from Nuremberg, Germany, shared his shock when he first noticed how quickly the object was moving. He was convinced it must have been discovered already, but this find was completely new. It's adding a whole new layer to the mystery of hypervelocity objects and sparking fresh curiosity about what else might be out there, waiting to be found. The discovery of CWISE 1249 opens up exciting new opportunities for exploration and study. Hypervelocity objects like this are typically stars, or remnants of stars, moving so fast that they're on the verge of escaping the gravitational pull of their galaxy. These extraordinary objects were first identified in the early 2000s and are often linked to powerful interactions with supermassive black holes, like Sagittarius A, the giant black hole at the heart of the Milky Way. But what makes CWISE 1249 truly fascinating is that it's different from the massive stars typically seen as hypervelocity objects. Unlike those enormous O and B type stars, this is a much smaller, low-mass object. So, how did something like this achieve such incredible speeds? There are a few intriguing possibilities. One theory is that CWISEJ 1249 was part of a binary system where one star was a white dwarf. As the white dwarf pulled in matter from its companion, it eventually triggered a Type 1, a supernova, blasting CWISEJ 1249 into space at breakneck speed. The idea is backed by the object's low metal content, which hints that it's an older star formed in a metal-poor environment. Another possibility is that this object might have interacted with a black hole. If it originated in a dense globular cluster, it could have been flung out by the gravitational forces of a nearby black hole. Either way, this discovery provides a rare glimpse into the mechanics of high-speed cosmic events and raises exciting questions about what other hypervelocity objects might be out there. Gravitational interactions within systems involving black holes can sometimes lead to rare but powerful events, like flinging stars out of their clusters and even out of the galaxy entirely. This is what might have happened with CWISA 1249. While these interactions are uncommon, simulations have shown that they can provide just the right amount of force to launch a star or object at incredible speeds. What makes this discovery so exciting is that it offers a rare opportunity to study low-mass stars and brown dwarfs, which are usually too faint and cool to observe in great detail, unless they're close by. But with this hypervelocity object racing through our galaxy, scientists can gather valuable insights that would normally be beyond our reach. This opens up new avenues for research into the formation and evolution of brown dwarfs and other low-mass stars, especially those originating from the distant, ancient regions of the Milky Way. CWISEJ 1249 isn't the only hypervelocity object out there. Over the years, scientists have found others, like the brown dwarf YSEAA, which also exhibited high-speed motion, though not as dramatically as CWISE. Even ancient stars within globular clusters have been observed undergoing similar ejections. Each of these discoveries adds another piece to the puzzle, helping us better understand the forces shaping our galaxy and the fascinating objects within it. Hypervelocity objects, whether they're stars or brown dwarfs, often reach these extreme speeds due to powerful gravitational interactions with black holes or supernova explosions. Over the years, several hypervelocity stars have been observed. For example, in 2010, a star named HE 437 5439 was found zipping through space at an incredible 1.6 million miles per hour, likely ejected from the heart of the Milky Way. Similarly, two stars named LAMOSTHV S1 and LAMOST, discovered by Chinese astronomers, are also on high-speed, unbound trajectories, showcasing the range of objects that can reach such astonishing velocities. This naturally leads to a question: could any of these hypervelocity objects ever collide with Earth? Fortunately, the answer is no. Objects moving at these speeds, like hypervelocity stars or brown dwarfs, usually have paths that either take them out of the Milky Way entirely or send them hurtling through vast, empty regions of space. Even though a collision is highly unlikely, studying these rapid travelers helps scientists fine-tune their models of stellar behavior and galactic dynamics. Finally, it's important to highlight the vital role of citizen science in these discoveries. Projects like Backyard Worlds, Planet 9 show just how much amateur astronomers, equipped with the right tools and guidance, can contribute to groundbreaking research. The discovery of CWISEJ 1249 is a perfect example of how collaboration between professionals and citizen scientists can lead to exciting new insights in astronomy. The discovery of CWISEJ 1249 is a testament to the dedication and passion of volunteers who have spent years contributing to this work. This collaboration between professional astronomers and citizen scientists is paving the way for even more groundbreaking discoveries, helping to expand our understanding of the universe. By broadening the research into ancient stars, and elusive brown dwarfs. Finds like this offer vital insights into the history and evolution of our galaxy. In NASA, astronomers have recently tracked an extraordinary object moving through space at hypervelocity, meaning it's traveling significantly faster than the typical velocities seen in our galaxy. This finding was made using data from both ground and space-based telescopes, which observed the object moving at millions of miles per hour. Hypervelocity objects are rare pieces of cosmic artillery, either stars or possibly smaller celestial fragments, that have been accelerated to speeds high enough to escape the gravitational pull of their home galaxy. The forces involved in catapulting these objects are massive and usually involve dynamic interactions with black holes or other dense cosmic bodies. The prevailing theory suggests that this object may have encountered the massive black hole at the center of the Milky Way. Such an encounter could provide the slingshot effect needed to propel it at such alarming speeds, sending it careening out of the galaxy. The study of hypervelocity objects is crucial for understanding the dynamic processes governing our galaxy. By analyzing the trajectory and composition of these fast-moving objects, scientists can gain insights into the behavior of stars near a galactic core and the powerful gravitational forces at play. NASA and other space agencies are keen to track more of these hypervelocity stars. Future missions may focus on mapping their trajectories to better understand the distribution of mass in the Milky Way and to test theories of gravity and stellar dynamics at extreme conditions. One of the main suspects behind the acceleration of hypervelocity objects is a supermassive black hole. The immense gravitational forces near the center of a galaxy can fling stars outward at incredible speeds, especially when a binary star system gets too close. The black hole captures one star while the other is ejected, creating a hypervelocity object. While many hypervelocity objects are stars, some could be remnants of exploded stars, such as white dwarfs, neutron stars, or even black holes themselves. Each type of object tells a different story about how it achieved such extreme speeds, whether through explosive events or close gravitational encounters. To measure the speed of these objects, astronomers use the Doppler effect, tracking shifts in the wavelength of light emitted by the object. By analyzing how light stretches or compresses as the object moves, scientists can determine both the speed and direction of these cosmic bullets. Once a hypervelocity object reaches escape velocity, it can leave the gravitational influence of its host galaxy entirely. These objects are on a one-way journey out into intergalactic space, potentially traveling billions of years before encountering another galaxy or star system. After leaving the galaxy, hypervelocity objects enter a cold, dark, and largely empty environment known as intergalactic space. They are no longer bound to any galaxy and can drift indefinitely through this vast, desolate void. Over time, they may encounter other galaxies or pass close enough to another gravitational source to alter their path. Determining where a hypervelocity object came from is a bit like cosmic detective work. By backtracking its current trajectory, astronomers can estimate where it was ejected and what event likely caused its acceleration. This process helps identify potential origins near the galactic core or other dense regions of space. There's also speculation that dark matter plays a role in the behavior of hypervelocity objects. Dark matter, which makes up a significant portion of the universe's mass, could influence the movement of these objects, subtly guiding or accelerating them through gravitational interactions that remain invisible to us. The outermost region of our galaxy, known as the galactic halo, is home to numerous hypervelocity objects. These objects offer clues about the distribution of matter in this distant, less understood part of the Milky Way, shedding light on how mass and energy are dispersed on galactic scales. While stars are the most commonly identified hypervelocity objects, the concept of hypervelocity planets also exists. If a planet were ejected in a similar manner to a star, it would become a rogue planet moving at extreme speeds, hurtling through space without a home solar system. Spotting hypervelocity stars is no easy feat. They are often faint, distant, and require precise measurements over time to track their motion. However, dedicated telescopes like the Gaia Space Observatory have been instrumental in detecting and cataloging these fast-moving stars. Studying hypervelocity objects can provide insights into the evolution of our galaxy. The process of ejecting stars and stellar remnants offers a glimpse into the dynamic and sometimes violent history of our Milky Way, helping us understand how galaxies evolve over billions of years. What happens to hypervelocity stars in the long run? Depending on their trajectory, they may eventually leave the gravitational reach of the Milky Way entirely, joining the sparse population of stars in intergalactic space, where they will continue their solitary journey until they burn out. For an object to escape the Milky Way's gravitational pull, it must reach a velocity of at least 1.2 million miles per hour, 2 million kilometers per hour. Hypervelocity objects are among the few things in the galaxy capable of reaching such incredible speeds, highlighting the dramatic forces at work. Though the discovery of hypervelocity objects is exciting, they are quite rare. Only a handful have been identified and confirmed, as most stars in the galaxy remain gravitationally bound to the Milky Way. However, ongoing observations may reveal more of these speedy travelers over time. Despite their high speeds, hypervelocity objects pose little threat to Earth. The galaxy is vast, and the odds of one of these objects intersecting with our solar system are extremely low. Still, their study gives us important information about the forces shaping our universe. NASA and other space agencies are interested in developing missions that can study hypervelocity objects more closely. These missions could include space-based telescopes with enhanced capabilities to track these fast-moving targets, and perhaps even probes designed to intercept or study them up close. Gravitational lensing, where the gravity of a massive object bends light, can also be used to study hypervelocity stars. By observing the light from distant galaxies as it passes near these objects, scientists can gather more information about their mass and velocity. The Milky Way's center is a hub of extreme activity, home to a supermassive black hole and countless dense star clusters. It's in this chaotic region where many hypervelocity objects are thought to originate, as close encounters with these intense forces can send stars flying out at breakneck speeds. In the coming years, advancements in both technology and data analysis will allow scientists to discover more hypervelocity objects and refine our understanding of their origins and trajectories. With each new discovery, we gain a clearer picture of the dynamic processes shaping our galaxy. While we've mainly discussed hypervelocity objects in our galaxy, similar phenomena occur in other galaxies too. Studying hypervelocity objects in distant galaxies could reveal whether they share similar characteristics and origins, deepening our understanding of universal forces. Galaxy mergers are among the most dramatic events in the universe, involving the collision and fusion of two or more galaxies. During such events, the chaotic gravitational interactions can create hypervelocity objects. Stars caught in these gravitational battles can be flung out at tremendous speeds, becoming galactic escapees. Star clusters, dense groups of stars bound together by gravity, can also be responsible for launching hypervelocity stars. When stars in these clusters interact closely, they can exchange energy and momentum. Occasionally, one star is ejected at high speed, while the remaining stars tighten their gravitational bonds. Some scientists hypothesize that dark energy, the unknown force driving the universe's accelerated expansion, might play a subtle role in influencing hypervelocity objects. While this is a speculative area of study, understanding how dark energy interacts with fast-moving stars could unlock deeper cosmological mysteries. Binary star systems, where two stars orbit a common center of mass, are often implicated in the creation of hypervelocity stars. If one of these stars is captured by a black hole, the remaining star can be ejected at incredible speeds. Studying these systems offers a closer look at the forces that create these rapid travelers. Another potential source of hypervelocity objects is supernova explosions. When a massive star goes supernova, the asymmetric blast can propel the remaining core, often a neutron star or black hole, at tremendous speeds. These hypervelocity remnants then race across the galaxy, carrying with them the scars of their explosive birth. While most hypervelocity stars are studied in visible light, astronomers are increasingly using infrared, radio, and X-ray observations to gain a fuller picture. These additional wavelengths can reveal details about the composition, temperature, and velocity of hypervelocity objects that might be invisible in optical light. Although hypervelocity stars are rare, hypervelocity black holes are even rarer. However, the possibility exists that small black holes could be ejected during dynamic interactions in dense star clusters or by other massive black holes. Detecting these objects is challenging due to their lack of direct emissions, but their presence could be inferred by their gravitational effects. Although hypervelocity stars are rare, hypervelocity black holes are even rarer. However, the possibility exists that small black holes could be ejected during dynamic interactions in dense star clusters or by other massive black holes. Detecting these objects is challenging due to their lack of direct emissions, but their presence could be inferred by their gravitational effects. The discovery of hypervelocity objects has captivated the public, leading to increased interest in astronomy. Citizen science initiatives, where amateur astronomers contribute data and observations, are helping professionals identify potential hypervelocity candidates. As these collaborative efforts grow, more discoveries could be on the horizon. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.